Hi, this is Alex from devstories.eu. Pulumi Infrastructure as Code, Episode 3 of 10. Setting up a cloud infrastructure project used to mean hours wrestling with boilerplate files and folder structures before you could write a single line of logic. Today, you can scaffold a complete environment in seconds. We are focusing on Hello Azure, creating your first project, to see exactly how that happens. A common misconception is that running the project creation command immediately builds infrastructure in the cloud. It does not. The command we are discussing only generates local files and prepares your state tracking. No actual Azure resources are created until you explicitly execute a deployment command later. To bootstrap a new project, you use the command line interface. First, you create an empty directory and move into it. Then you run the command pulumi new, followed by a template name. For Azure, this template is usually Azure- and your programming language of choice, such as Azure-TypeScript or Azure-Python. When you execute this, the interface becomes interactive. It walks you through a series of prompts to configure your environment. First, it asks for a project name, which defaults to your directory name. Next, it asks for a project description. Then it asks for a stack name. A stack is an isolated instance of your project, usually representing an environment like development or production. The default stock is named dev. Finally, the Azure templates prompt for an Azure location like West US, which will be saved as your default deployment region. Once you answer the prompts, the tool downloads the template, installs the necessary language dependencies, and creates a handful of files in your directory. Here is the key insight. The most important file generated is pulumi.yaml. This is your core project file. It defines the project name, the runtime it uses, and the description. It essentially tells the system how to execute your code. You'll also see a file named pulumi.dev.yaml if you accepted the default stock name. This secondary file stores the configuration values specific to that stack, including the Azure region you just selected. Alongside these, you get your standard dependency files, which vary depending on your chosen language, and your entry point file. Inside the entry point file, the default Azure template provides a working example of an Azure storage account. The code logic flows in 3 clear steps. First, it imports the Azure native package. Second, it declares a new Azure resource group, giving it a logical name for the state file to track. Third, it declares an Azure storage account. This is where it gets interesting. Instead of hard-coding the resource group name, the storage account takes the name property directly from the resource group object created in the previous step. This creates an implicit dependency. The system now knows it must finish creating the resource group before it attempts to create the storage account. The template also automatically fills in required arguments for the storage account, like the account replication type and the account tier. At the very end of the file, the code exports a value. In this scaffolded example, it exports the primary storage key of the newly defined Azure storage account. When you eventually deploy, this exported value will be printed directly to your console, making it easy to retrieve connection strings or endpoints without logging into the Azure portal. You go from an empty folder to a fully wired infrastructure program simply by answering a few prompts, giving you a solid syntax-correct foundation to start building your own architecture. Thanks for listening. Happy coding, everyone.